Hello, PyOhio 2023. My name is Jack Bennett, and this is my talk, Orchestrating Workflows as a Chronic Systems Problem. Airflow is the modern solution. First question, what is Airflow? The answer from the documentation is Apache Airflow is an open source platform for developing, scheduling, and monitoring batch-oriented workflows. So what's a workflow? A workflow is a set of related tasks that we want to run automatically in a specified order on one or more hosts. So, what's a task? A task is basically something that we want the computer to do. And three examples are get a file from S3, export data from a table, process a data frame in pandas. Basically, computer, do this. When we say related tasks, these tasks have dependencies on each other or on external conditions. And this is really where Airflow shines. So dependency, thing one has to happen before thing two happens. This could be internal to Airflow or external to Airflow. Typically, when it's internal, an upstream task finishes running, and that allows a downstream task to start. In the external case, data arrives, a service becomes available, a server load reduces, or the classic case that we see in cron, as well as in Airflow itself, time reaches a particular point, the clock strikes midnight, and we can run a particular job. Now, here's a case where it's simple enough that we could actually run it from cron. We have a little graph of 4 tasks, A, B, C, and D. A starts. When A completes, B and C can start. And then when B and C are finished, D can start. We'd have to wrap these tasks in scripts and manage a bunch of lock files. But in principle, it's possible to do this with cron jobs. Now, here's a case where that would be really terrible. This is a graph of 40 different tasks. The different dependencies are very complex. So it's not something where you would want to do the wrapper script plus lock file cron job activity. It would be really, really quite painful. And this is actually a screenshot from Airflow. It's in this type of complex task dependency situation that Airflow does really well. Here's a comparison of the two. Fundamentally, cron is a much, much older piece of software. It was started in 1975, almost 50 years ago, and it was in a single host environment. It's meant for scheduling jobs, independent jobs in walk clock time, whereas Airflow was first created in 2014. It grew up in the world where web UIs were common, and really an interesting aspect of Airflow is that almost everything is programmable and specifiable in Python. So you can create very complicated graphs of interdependent tasks, which would be really, really challenging, if not impossible, in cron. So it's not that one is better or worse than the other. They're really just two different tools that were created for handling similar but yet not identical situations. Cron is used for running independent tasks in series on a fixed schedule. Airflow is used for running a complex workflow of interdependent tasks. So what's a DAG? This is the conceptual model really at the heart of Airflow. And that is a directed acyclic graph. This is a complicated example of one showing nodes in the blue ovals and then edges between them showing task dependencies. So if each node, each blue oval represents a computational task, then the edges show how one depends on the other. So for example, 41 here on the left would have to have number 52 complete before it could start. So this is a DAG, or a directed acyclic graph of different tasks showing dependencies between them. Why do we use DAGs? essentially it's the flow of time and dependency. We show a graph because tasks are individual nodes and they have relationships. So graph is the natural kind of data structure to use here. The graph has to be directed because things happen before and after other things. There's dependencies and time ordering. And it has to be acyclic because there has to be a starting point. Cyclic workflow would not be able to start or might possibly never end. That's not the situation we want. So a workflow with a definite start and a definite end has to be acyclic. So let's get concrete for a little bit. We'll take a look at what this actually looks like in the browser. So here is the Airflow UI showing two different DAGs. These are just rows in a table. So we'll click on an example. This is provided within the standard install. So on the left here, these bars represent the time taken by the DAG to execute. And these little squares show success, or in the pink case, these tasks got skipped. So you have a rich capability to control the execution of different DAGs. And you can view it as an actual DAG. Here's the DAG representation of this particular workflow. Here's the code. And so we have Python imports. We have the definition of the DAG in a context. These are individual tasks. And then this bit shift operator shows the dependencies between different tasks. So this DAG, represented as such, is actually defined completely by this Python code. So we can run this. We'll click on it, hit trigger, and a new column appears here. Light green means it's running, dark green means it's succeeded. It runs very quickly because these are very, very simple tasks. We have a bash operator that runs a bash command. We have empty operators that do nothing. And so this shows how a simple DAG will operate. Here's a slightly more complicated one. And this gives you an idea of the capabilities of Airflow. Here's 40 different tasks in a single DAG. Each of these is an empty operator, so they're individually trivial, but the connections between them are quite complex. We start this, and we can see them running and immediately succeeding. We have a code here showing the standard pattern of defining a DAG in a Python context. And all of these tasks are defined within 20 lines of code. Most DAGs with 40 different tasks would not be so simple because we're not actually making them do anything. But this is a useful way to lay out your tasks before actually going and writing the code within them, to define the relationships between the tasks before the specifics. So that's a quick little introduction to Airflow and the UI. So that was run from Docker. You can see the web UI and some functionality and how workflows are defined as code, how you can view the code, as well as the actual DAGs themselves and how they operate. So what's the architecture of all this? It's fairly straightforward. Over here on the right, we saw the UI and the web server. Under the hood, there's a scheduler and an executor that handles ingesting the DAGs, verifying that they're well formed, dealing with the database where the metadata is stored, and then parceling out different tasks to different workers. The workers may run on different hosts. So in a large install, you might be running on multiple different virtual private servers or physical servers, depending on your preference. You're going to see in Airflow certain terminology that recurs over and over, including operator, sensor, hook, connection, XCOM, provider, and plugin. We'll take a look at a few of these quickly. An operator is basically a common Airflow task that you've bundled together as a Python class. So the operator is the class, and a task, you instantiate that class and it becomes a specific task. Really, the purpose here is to factor out redundancy for very common tasks. For example, the bash operator we saw executes a bash command. And similarly, Python operator calls a Python function, email operator sends an email, and there are dozens and dozens more already defined operators that you can use for your purposes. A sensor is actually a more specific category of operator. It will look at an S3 key or a Jenkins build or any number of things. You can look at databases or different hosts or an API and detect when a condition is met so that you can then launch a DAG or a task. A hook is an interface, so you can have an SSH hook, SFTP hook, Postgres hook, and these are used extensively within operators themselves. Connections, this is really useful because Airflow has to be kind of this nerve center that connects to so many different resources. This is a mechanism for collecting your credentials to connect to different resources. And each resource has its own unique identifier called the connection ID. And so instead of storing passwords in code or in plain text or other insecure ways, you essentially use this connection ID as a handle to talk to these different resources. So it's a very effective way of centralizing all of these necessary credentials. XCOMs are an important part because when you specify the DAG in code, that code doesn't actually execute sequentially on the same host. Tasks can execute anywhere. So data created by one task isn't necessarily available to the next task unless you follow this mechanism. You can store data using XCOM push and retrieve it using XCOM pull. And that way, tasks that execute on different containers or different hosts are able to communicate and pass data from one to the other. A key thing to note about this is that you should only use it to transfer small amounts of data. You shouldn't be pushing around gigabytes of data between different tasks. In the case of big data tasks, you probably want to write out to a database, write out to a data store, or S3 object, something like that, rather than push it through Airflow proper. Airflow is not designed to move around these big data components. Instead, you should use more appropriate tools for that. Alternatively, if you already have a shared data store, you can use that instead, write to that within a given task, and it'll operate the same way for you. So zooming out, what is the big picture here? Airflow is a very active, very well-developed open source project. Almost 800,000 lines of Python code, over 20,000 commits, tens of thousands of stars and forks, and almost 3,000 contributors. It's mostly a Python project, although the front-end UI is written in TypeScript, JavaScript, HTML, CSS, all that stuff that you'd expect. And it's coming up now on about 10 years old. So if you decide you want to use Airflow, how would you pitch it to your CTO? These are points that you might want to make. It's a well-developed open source project, has a long development history, very active user community, a lot of good documentation, tutorials, and examples. There are a lot of resources out there for getting your devs up to speed, and managed solutions are available as well. So it really is ready for enterprise use. It's in use in large and small companies all over the world, and it could be in use in your company as well if you have a need for it. In terms of learning, lots of good references. The official documentation is really good, and there is one published book so far if you learn better through that. Likewise, there are tons of videos, YouTube videos, tutorials, etc. online that you can leverage to learn more about Airflow. So I hope that's been a good introduction. Thank you very much for your time.